Okay. In this video, I'll be discussing solving systems of equations and how to solve linear and nonlinear systems of equations. Substitution elimination. We've discussed this in the past, so quickly to go through. Substitution is when you are literally substituting an expression for a variable. 2x minus 7 is equal to y. So therefore, I can substitute y in for what it represents. So 4x plus 3y equals 4. And y actually represents 2x minus 7. And therefore, to solve, I would distribute the 3 and get 6x minus 21 equals 4. 4x and 6x give you 10x. I would add 21 to both sides and get 25. So x represents 2.5. Now, I'm almost done. I now need to take 2.5 and plug it back in to find my y. So 2 times 2.5 minus 7. 2 times 2.5 is 5, and 5 minus 7 is negative 2. So the solution to this equation, or systems of equations, would be 2.5, negative 2. And if you were to graph these two equations, they would cross at this point on the graph. Now in this case, we would probably use elimination because we don't really have an expression that is solved for a variable. So we need to either eliminate the y's or eliminate the x's. So I'm going to eliminate the y's. I have 2 and 3. I need to come up with the least common multiple, something back from Algebra 1, to figure out how to make a 2 and a 3 both give you the exact same answer. So I know that if I multiply, well, the least common multiple of 2 and 3 would be 6y. So to make a 2 become a 6, I need to multiply the top equation by 3. And in order for a 3 to become a 6, I need to multiply the bottom equation by 2. So when I do that, I need to multiply everything by 2. So 3 times 5x is 15x. 3 times 2 is 6y. And then negative 19 times 3 is a negative 57. The bottom, I multiply by 2. I get 4x plus 6y equals 0. Now I can add these two equations together because when I do, a negative 6 and a positive 6 eliminate each other, hence elimination. 15 and 4 give me 19x equals negative 57. Divide both sides by 19 and I get x equals negative 3. Now I need to plug this term back into one of my equations to solve for y. So I'm going to take my second equation and I'm going to plug negative 3 in for x. 2 times negative 3 is negative 6. I'm going to add both sides with 6 and then divide by 3 and I get 2. Therefore, my point negative 3, 2, it would be a solution of the systems of equations. Now, word problems do the exact same thing. As you read the word problem, you will be able to write the answer or write the equations out. So let's look. Example, a total of $50,000 invested into two funds paying 8% and 10% interest. I am going to use the letter E to represent the, well, I would say letter E to represent the amount of money invested at 8% interest. And I'm going to use N to represent the amount of money invested at 10% interest. So I know that if I add up the amount of money between E and N, it is going to give me $50,000. I also know that the amount of interest that they will receive is $46.60. So at 8% interest for E and the 10% interest for N will yield me a total of $4,660. And in this case, I would use elimination in order to solve how to actually do these problems. At the end of this video, I will go back and solve this if anybody would like to see it, but I'm going to move on at this moment. A boat can travel 24 miles in 3 hours when traveling with the current. Against the same current, it can travel only 16 miles in 4 hours. Find the rate of the current and the rate of the boat. So I'm going to use C for the current, and then I'm going to use B for the boat. Now, think about this as in a boat is traveling in a certain amount of hours. So we're going to use the formula, the distance equals rate times time. The distance that the boat traveled is 24 hours. The rate of him traveling with the current, so the boat speed plus the current speed is the rate. The rate, again, is the boat traveling with the current, so you add them together, and you multiply that by time. It took 3 hours. Against the current, it only travels 16 miles, so the distance is 16 miles. The rate is the fact that they are traveling against the current. So I'm going to take the boat and subtract C because the currents or the rates are going against each other, and it took them 4 hours. So we have the equations 24 equals 3B plus 3C, and we also have the equation 16 equals 4B minus 4C. Again, I will solve this at the end of the video, but for now I'm going to continue on. Nonlinear systems, in this case, you have more than one solution that's going to happen because you have an x squared and you have a y squared. Many of the same properties are the same, In nonlinear systems, it's a little different because you will have more than one solution to this problem. You have an x squared and a y squared, so there's more than one answer that could possibly work for both equations. You can solve this in very similar fashion though. For example, I have a positive y squared, I have a negative y squared. So if I add these two equations together, they will eliminate each other. X squared and 2x squared give me 3x squared. 5 plus 7 give me 12. I can solve this equation because I have one variable. I would divide by 3 and I would get 4. If x squared equals 4, then I would take the square root of both sides, and when I do that, I get plus or minus 2. Here's where it becomes different. We actually get two different answers, which means if x equals 2, then we possibly are going to get different answers for y. So let's go ahead and plug in 2. I'm going to plug into the top equation. So I will get 2 squared plus y squared equals 5. 2 squared is 4. If you subtract 4 on both sides, you get y squared equals 1, which means y equals plus or minus 1 when you take the square root. Therefore, if x is 2, then you would have the solution 2, 1, because you have a positive 1 for y, but also the solution 2, negative 1 also works because if you plug in 2, you actually get 2 answers. Now, that is only if we plug in 2. If we plug in negative 2, because remember, at the very beginning we had 2 solutions, if x equals a negative 2, we also need to figure out what the answers are. So if I plug in negative 2 squared plus y squared equals 5, I will get a positive 4 still because a negative squared gives me a positive. So I subtract 4, I'll get y squared equals 1. And so again, I will get y equals plus or minus 1 because I took the square root of both sides. So when x is negative 2, I also get 2 answers. So when x is negative 2, I get 1, and I also get negative 1. And these, all 4 solutions will work in both equations. In this nonlinear systems, it is a little bit different in the fact that the x's are both squared, but the y's are not. That is going to alter what this is going to look like in the end. So let's go ahead and work through it. The x squares can almost be eliminated. We need opposite signs to do that. So I am going to multiply the bottom equation by a negative. On top, nothing changes. And on bottom, that gives me a negative x squared, a positive 3y, and that equals a negative 3. Now when I add the equations together, the x's eliminate each other. I am left with y squared plus 3y. Do not add y squared plus y to give you y cubed. You're adding two different terms together. You cannot combine exponents. You can only combine exponents when you're multiplying. And then 1 and negative 3 give you negative 2. Now, anytime you have two different expressions that have a variable, the only thing that you can do is set it equal to 0. So I'm going to add 2 to both sides, set it equal to 0. This factors into y plus 2 times y plus 1 equals 0. Therefore, y equals negative 2. Y could also equal negative 1. So what we need to do is we need to plug negative 1 back into an equation to see what the answer is, and then plug negative 2 back into the equation. So let's start with negative 2. So if I plug, if y equals negative 2, I'm going to plug it into the top equation. I will get x squared plus a negative 2 squared equals 1. So x squared plus 4 equals 1. I'm going to subtract 4, and I get negative 3. And at this point, I need to take the square root of both sides, and I'll get x equals plus or minus I times the square root of 3. Don't forget, a negative square root brings out an I. Now, that is if y equals negative 2. Now, let's suppose if y equals negative 1. I will get x squared plus negative 1 squared equals 1. Negative 1 squared is still a positive 1 because when you square it becomes positive. So when I subtract 1, I will get 0. Take the square root and I get 0. So the solutions to this system of equations, we've learned that if y equals negative 2, x can give me two different options. I could get a positive I squared root of 3 when y is negative 2. I can get a negative I square root of 3 when y is negative 2. Again, don't forget, y value is negative 2, not the x. And then I also realized that when y is negative 1, I could get 0. These three solutions will work for both equations. If you were to graph these two equations together, they would cross in 3 different places. Now in this nonlinear system, it is a little bit different because x and y are multiplied together. So what we're going to have to do is I'm going to add 1 to both sides, and then I'm going to solve for x to leave 1 over y. Now I'm going to I'm going to substitute 1 over y in for this x. So 2x minus 4y plus 7 equals 0. So I'll get 2 over y minus 4y plus 7 equals 0. Now, I cannot solve when there is a variable in the denominator, so I'm going to multiply the entire equation by y. When I do that, I'll be left with 2, because y divided by y is 1, minus 4y squared, because y times y is y squared, plus 7y equals 0. So what I'm going to do is I'm actually going to get everything on the other side of the equation because I don't want to have a negative along with the y squared. So 0 is going to be on the left-hand side. I added 4y squared to the right side. That means I'm going to have to subtract 7y to the other side. And I'm also going to have to subtract a 2 to the other side. When I do that, I can then factor this. So 4y squared minus 7y minus 2 is going to factor. And here's how we do it. You will use the illegal move. 4 times negative 2 is negative 8. And the negative 7 is in the middle. What multiplies to give you negative 8 and adds to give you negative 7? Negative 8 and a positive 1. So I will have y minus 8 and y plus 1. But the illegal move says we now need to undo the fact that we multiplied 4 times 2. So now I need to divide by 4. So I will get y minus 2, because 8 divided by 4 is 2, This does not divide out, so you pull the 4 in front of the y to set equal to 0. So you'll have two answers. Y will equal 2, and y will equal a negative 1/4, because to solve for this, you'll get a negative 1/4. Now that is y. Now in order to find your x value, I'm going to plug 2 back into this equation. So if y equals 2, then x equals 1/2, and x equals 1/2. So we have the coordinate point 1/2, 2. If y equals a negative 1/4, then x is going to equal 1/, that negative 1/4, which KFC, keep it, flip it, change it, is going to give us a negative 4 for our answer. So we would have the coordinate point -4, -1/4 for the solutions to this system of equations. This equation, I'm going to do it through elimination, and I'm going to multiply the top equation by a negative 0.1 n so that I can cancel the n's. So I'll get a negative, which you can say negative 0.10 or negative 1, it doesn't matter. Not n. Negative, I'm just going to say 0.10. Negative 0.10 e minus a 0.10 n equals a negative 5,000. And on bottom I'll have 0.08 e, a positive 0.10 n equals 4660. Now when I add these two equations together, this will give me a negative 0.02 e equal to a negative 340. Now when I divide by 0.02, I will get $17,000. That means that $17,000 was invested in the 8% simple interest fund. Therefore, $33,000 must have been invested in the 10% interest fund, because they have to add up to $50,000. In this case, when we're eliminating a variable, I noticed that 24 equals 3b plus 3c all have a multiple of 3 in the entire equation. So I'm going to divide the whole thing by 3. And when I do that, I'll be left with 8 equals b plus c. When I divide by 3, divide by 3, divide by 3. You can do it as long as you do it to everything. Same thing with the second equation. I can divide everything by 4. And when I do that, something nice happens. The c's will end up canceling very easily. So when I add these two equations, the c's cancel, leaving me 12 equals 2b. Divide by 2, which means 6. Therefore, the boat had a current of 6 miles per hour. To find the current, I'm going to take this top equation. 8 equals b plus c, but instead of b, I can put in the number 6, subtract, and I will get 2. Therefore, that means the current had a rate of 2 miles per hour.